In this problem, we're going to determine the center of mass of this homogeneous solid block. This is also a composite body. It can be considered to be made up by this triangular shape, body number 1. The second one, don't forget, we actually have to include this part right here. So this block is body number 2, and then this another triangular one is number 3. And because it's a homogeneous solid block, therefore its mass center is the same as the centroid of its volume. And we can use the equation that x bar equals to the summation of x tutor v divided by summation v. And v is the volume of the individual component body. And x tutor is the centroid coordinate, x coordinate for the centroid of the component body. And same thing with y bar and z bar. So again, we're going to use this table to do the calculation. We have body number 1, 2, and 3, and we need to determine its total volume. And then x tutor, y tutor, and z tutor for each of the component body. And then x tutor times v, y tutor times v, and then z tutor times v. So for the first triangular block, its area, this triangular area is 1.5 times height 1.8. So 1/2 times 1.5 times 1.8 with a width of 0.5. So if you do the calculation, its volume is 0.675. I use a different color. And the unit is meter cube. So for body number 2, it's a rectangular block. The area is not 2 times 1.8, but 2.5 times 1.8 times the thickness of 0.5. So 2 plus 0.5, 2.5 times 1.8 times 0.5. And that equals to a total volume of 2.25 cubic meter. Lastly, for this triangle right here, its area is 1/2 times 1.5 times 1.8. Thickness is 0.5, so it's the same as body number 1, 675. So after we have calculated these volumes, we need to determine the x tutor, y tutor, and z tutor for these blocks. Let me give an example of number 3. For number 3, its x direction, along the x direction, its centroid is here. That is 1/3 of its height, total base, which is 0.5 meter, plus all the way from here to here, that's going to be 2.5. So its x tutor is 2.5 plus 0.5. Therefore, sorry, that's along the y direction. So y tutor is 2.5 plus 0.5. Okay, that is 3. And then along the z direction, is from here to here, that is 1/3 of its height, 1.8 meter. So that is 0.6 meter. And along the x direction, the total thickness here is 0.5. Its centroid is located at the center. Therefore, that's going to be a half of 0.5, 0.25 meter. So that's for block number 3. And we can do similar analysis for block number 1 and 2 and fill this table in. So that'll be 1, 0.25, 0.6, and then 0.25, 1.25, and 0.9. And then we can calculate these 3 remaining columns to get this result. If you have, for example, Excel, I suggest that you use the Excel to handle this type of calculation. Now, we're going to add up the total volume. That's what goes into our denominator. So that's going to be 3.6. And then add up x tutor v, 1.4063. Add up y tutor v, 5.007. Add up z tutor v, 2.835. Now we're ready to do the calculation. X bar equals to summation x tutor v over total v, which is 1.4063 divided by 3.6, and that equals to 0.391 meter. Y bar equals to summation y tutor v over summation v, which is this number, 5.007 over 3.6, and that is 1.391 meter. And lastly, z bar equals to summation z tutor v over total volume. So this number, 2.835 over 3.6, and that equals to 0.788 meter. So that will be the final answer. So these are the coordinates, x bar, y bar, z bar, of the centroid of volume for this homogeneous solid block. And because it's homogeneous, centroid of a volume is the same as the center of mass because the density is the same everywhere.